So this is a trigonometry question. So let's try to find the value of this. So in this type of scenarios, although there is square here, so you have to think there are three terms. So you can actually turn this either a plus b whole square or a minus b whole square. So when I say a plus b whole square, I can actually take it as 1 plus sine theta minus cos theta. So this turns into a and this turns into b, so as a whole square. But the problem here is when we square, again b square actually has to be, again this, if I take it as a and b inside, there will be sine square theta plus b square, which is cos square theta, plus 2 sine theta into cos theta. So this option, what actually happens is you might not be able to get rid of this. So instead of that, what you can try is you take that as a, that as b. So when I say that as a, so this will be a and that will be b. So if I'm actually going to consider it that way, then a minus b whole square, it might work. But most of the time what you can try is, in this type of scenarios, like we used to do rationalizing denominator, so you need to find out, similarly you find out a and b, but try to rationalize the denominator. But here it's exactly not rationalizing denominator. So if you are rationalizing denominator, usually what you do, if there is something root 5 plus root 2, you would have done multiplied by root 5 minus root 2. That's a rationalizing factor, root 5 minus root 2. That way actually we are trying to make this rationalized. But here, because at the end of this question, somewhere in between, we need to use identities. So to use identities, if I am actually going to come up with that, if I take that part as b, I'll be left with this. I'll not be able to substitute this value with any other identities. So instead of that, we'll use that as a and b, but we'll use this as a and b and try to use that method, and so that we can simplify the denominator and as well as the numerator. So let's start with that. So keeping that in mind, we'll work on that. So if that is okay, that square, keep that in mind, we still have to square once we get that. So 1 plus sine theta minus cos theta divided by 1 plus sine theta plus cos theta. So like I said, I'm actually going to put bracket here, So keep taking that rationalizing factor as concept, but the main thing is when we took rationalizing denominator, all we did is, in the denominator we had a plus b into a minus b. That actually gives me a square minus b square. So that's the idea behind this. So here if I take this as a plus b, and if I multiply with sine theta minus cos theta, just changing the sign, and 1 plus sine theta minus cos theta. So let's verify. If I cancel this, value didn't change, but the bottom one looks like a plus b, a minus b. So what I can do is, a plus b into a minus b gives me a square minus b square, which is 1 plus sine theta whole square, that is a square, minus my cos theta whole square, 1 square minus a square minus b square. So the top one actually looks like, that is a, that is b, that is a, that is b, a minus b, a minus b, which is a minus b whole square, which is identity a square plus b square minus 2ab. Let's use that. A square is 1 plus sine theta whole square plus b square, which is cos square theta. Straight away I'm going to write that, plus 2ab plus, no, it's minus 2 multiplied by a is 1 plus sine theta, then into cos theta, right? Let's see what happens. So now 1 plus sine square theta is again a plus b whole square, a square plus b square plus 2ab, a square plus b square plus 2 into 1 into sin theta, 2 sin theta plus cos square theta. So now we will keep it as is. We will see if needed, then only we'll expand this. The reason is, if I expand this, there will be minus 2 sin theta cos theta. Again, like we discussed, 2 sin theta cos theta will appear there. So we'll see if we cannot get anything here that gets cancelled, or if we get something which is going to get cancelled, then we'll multiply and then we'll see how to go about it. Divided by, I have a square minus b square, which is a square. Here again I can use a plus b whole square, which is a square 1 square plus b square is sin square plus 2ab plus 2 sin theta minus cos theta square is cos square theta. So that's what we have. We will see what happens with that. Maybe 1 square. Okay, fine. As you can see here, sin square theta plus cos square theta is 1. So that makes it 1. I'll keep 1 as 1. Sin square theta plus cos square theta, I'll put one more 1. Then plus 2 sin theta minus 2 1 plus sin theta into cos theta, right? Divided by, I have 1 plus sin square theta plus 2 sin theta, and anything is fine. So what we'll do is minus cos square theta, I'll change it to 1 minus sin square theta. We can change it later, but I'm going to put it now, because that way actually I think that I can make all of them into sine. Then here, look at numerator, that is 1 plus 1 is 2, and there is 2 in this term, there is 2 in this term, so I can actually take 2 common, right? If I take 2 common out of these 2, that is 1 plus sin theta minus 2 will not come, right? 2 are already taken. 1 plus sin theta and cos theta is left. Let us put bracket. Divided by, what's going to happen here? 1 plus sin square theta plus 2 sin theta minus 1, minus into minus, plus sin square theta. So I get here you can see, although there are 3 terms, I can see that particular part. If I put bracket, it doesn't hurt because value doesn't change if I put bracket. And inside that, if I take 1 plus sin theta out of this, if I take 1 plus sin theta here for entire this, I'll get 1 minus 1 plus sin theta I've already taken, I'll be left with cos theta. So let's find and verify this. 2 is there, 1 plus sin theta into 1 plus sin theta, 1 plus sin theta into cos theta, 1 plus sin theta into cos theta. So value didn't change, I've just taken the common. Here 1 plus 1 and 1 gets cancelled, as you can see. So I'll be left with sin square theta, 1 sin square theta, another 2 sin square theta plus 2 sin theta. And I'll take out these 2 here itself and then take 2 common so that I can get rid of these 2 here itself. So next, I have this, I can't do anything. Even if I multiply, I'll get back the same numerator as before. So we have to work on the denominator. 1 plus sin theta, 1 minus cos theta, divided by, if I take sin theta common, I'll be left with 1 more sin theta plus 1. Let's verify that. Sin theta into sin theta, sin square theta, sin theta plus multiplied by 1 sin theta. So 1 plus sin theta or sin theta plus 1, they get cancelled. I'll be left with 1 minus cos theta divided by sin theta. But remember, we have to square this as well. So if I square, what is going to happen? That is 1 minus cos theta. I will not square until it is required. I'll put this as 1 minus cos theta whole square, the numerator. Denominator will be sin square theta. Sin square theta, if I expand that, use identity 1 minus cos theta whole square divided by, that will be 1 minus cos square theta. This 1 minus cos square theta can be written as, this looks like a square minus b square. So that means I can actually write it as 1 plus cos theta and 1 minus cos theta. Here 1 minus cos theta whole square. 1 minus cos theta, 1 minus cos theta goes, you will be left with 1 minus cos theta divided by 1 plus cos theta. That should be your answer.